It's an interesting topic. Alrighty, so today I'm just finishing the chapter. So we're going to come to the end of our chapter on memory, and we've spent so much time talking about lists and remembering lists of words. That's where we're going to start today, because they've actually done enough studies on how we remember the things in lists that they actually have sort of rules and ideas on how we remember particularly things in the order that they occur. And so this effect is called the serial position effect. So it describes the relationship between a word's position in a list and its probability of recall. And this is based on two concepts. The first is the primacy effect, that basically says it's easier for us to remember things at the beginning of a list. And then the recency effect specifies that it's easier for us to remember things that have happened most recently, i.e. the end of the list. And so if we can kind of visualize what's going on there, if we remember the early stuff and the late stuff, then our graph of recall should look something like this, where if we have our serial position along the bottom, this is 20 words in a list, and then our probability of recall, and we get a nice U shape. So we're good at remembering the early stuff and the late stuff. And what they were trying to do is explain why we see this. Why do we remember the early stuff, but also the late stuff, but not the stuff in the middle? And the idea is that we're starting to see the movement of things going from short-term or working / immediate memory into long-term memory. So our primacy effect would actually be that start of encoding, moving information into sort of long-term storage. And then if that's what's happening there, then recency would actually just be our short-term memory or our immediate memory holding that information. And so we can't necessarily test if it's long-term encoding happening at the beginning, but we can test if it's the recency effect is due to our short-term memory. And that's basically just wait a couple of seconds. Wait for the duration of what our immediate memory should be able to hold and see if it goes away. And lovely enough, that is exactly what they see. I'm so tongue-tied today. But our purple line is immediate testing. So exactly what we saw in the previous slide. We see primacy and recency if we test immediately after giving them the list. So you'd give them a list of 20 things, you'd test them on a list, and you see which ones they recall. And so if we delay the test by 30 seconds, and specifically you'd probably be doing something to keep them from rehearsing. So maybe you ask them to do a math problem or ask them about something else, just enough to get it out of their short-term memory. And then the recency effect drops off entirely. But the primacy effect doesn't go anywhere. In fact, we see almost no change other than just the lack of recency. So it tells us that, yeah, the primacy is probably that stuff is being encoded into long-term memory. And we can only encode so much at a time. So the earliest stuff does the most encoding, and then it drops off pretty quickly. And then recency is just short-term memory, whatever we can hold in our current store. All right, so that's remembering. Today we're actually going to be focusing almost exclusively on forgetting, so the opposite. And we mentioned at the beginning that when we forget things, it's actually usually a failure to retrieve. So we've encoded stuff, but we can't go and get it. But there is the possibility that there was no encoding to begin with. And if you think of the sort of span of our different pathways in memory when we started incoming sensory information to our sensory memory, if we didn't pay attention at that stage, the information would be lost immediately. So we could forget at that first stage in sensory memory. Or if we paid attention to it, brought it over into our immediate memory, but didn't do anything with it, it would pass out of our awareness and then be forgotten at that stage. We didn't process it or encode it in any way at the later stages. We only focused on the important details, so most of it gets lost at that stage. So in those situations, that would be an encoding failure because we never took that information all the way to long-term storage. But if something does make it into long-term storage, then how do we not be able to retrieve it? What happens there to interfere with retrieving stuff out of long-term storage? And one of the theories is this idea of the decay of memory trace. And this actually kind of lines up nicely with the example that I've used throughout the chapter, talking about a pathway leading you to an item. And so that's the idea of, okay, so if I walk to that particular thing over and over again, the path is more solid and stronger, and it's not going to go away. And so the opposite of that would be if you stop walking that path, then it'll grow over. It's going to go away with disuse, and it goes with the idea of if you don't use it, you lose it. So that trace in our minds, that sort of pathway in our minds, will fade with disuse as time goes on. And this is thought as sort of the decay of memory trace theory, or the decay theory of forgetting. It's meant to be sort of an everything goes away over time, but that's not really true. So the best example of this is if you're sitting and listening to the radio and a song comes on and you get that wave of nostalgia and you're like, oh, I haven't heard this since middle school, but you still know all of the words. You haven't been using that. It's been years, and yet you still know all of it. So that shows us that not everything decays over time. Some things, yes, but not everything. So there's very little evidence for this being an sort of apply it everywhere kind of a theory. It doesn't tell the whole story. What we do see a lot more evidence for is the interference theory of forgetting. And this basically says that information gets forgotten because other things in our long-term memory impair or get in the way when we're trying to retrieve it. And for this one, I always use diagrams because it's another of those directionality things, and that does not work for me. But we have proactive and retroactive interference. And so retroactive is the one on the top, where new memories interfere with the recall of old memories. So we're having issues with older or retro things. And so the example that I use for this is if you're learning two different languages, or I guess if you know two different languages. So you started knowing Spanish and then you learn French. And so retroactive would be saying that your new language, French, is going to interfere with the recall of Spanish words. So because French is fresh in your mind, it's getting in the way when you reach for the older thing. We also have then the opposite, proactive interference. And this goes in the other direction, saying that old memories interfere with the recall of new memories. And so with that same thing, we'd be saying, okay, so Spanish and French, but now old Spanish is interfering with the recall of new French words. So I've known Spanish for so long that that's what I think of first, and I can't for the life of me remember the newer words. They're getting in the way. And again, these aren't supposed to be sort of one or the other. They're not mutually exclusive. We tend to experience both. So sometimes new things get in the way of old things, and sometimes old things get in the way of new things. And we see a lot of evidence for this happening, where it's basically we can't reach for the right thing because something else pops to mind. All right. Our next concept is the 7 sins of memory. And they're broken down into 2 categories. The first are the errors of omission, and the second is the errors of commission. And so omission just means that information is left out. Commission means that there's extra information, and we'll get details on those. But for our proper definition, errors of omission are memory errors where information cannot be brought to mind. So you cannot remember something. And there are 3 basic types. Transience goes along with that idea of memory for a particular event will degrade over time. So again, not for all situations, but sometimes as things are sort of not used over time, they just sort of disappear. We have absent-mindedness. That's the idea that memories they are unavailable because we never encoded them in the first place. So either we didn't pay attention to them or we didn't process them enough and we just never encoded them. And then the last one is blocking. And this is one that's most common, where there aren't enough distinctive cues available to us to help us recover a specific memory. So this is that idea of, I physically can't remember what it is. It's on the tip of my tongue. I know that I know it, but I can't remember it. And a great example of this that happens all the time with my parents is we'll be talking about an actor. And they're like, oh, it's that person who was also in this other movie. What's their name? And I have no patience for that. So I look it up on my phone. And they're like, don't tell me. Don't tell me. And you sit there for like a minute, 2 minutes. And finally they're like, what's the first letter? And as soon as you get the first letter, they know exactly who it is. So I provided enough of a cue to overcome that blocking. So it was blocked from their memory until we added extra cues, and then they know exactly what it was. So it's kind of like they weren't quite sure where the path started, and as soon as you pointed them in the right direction, they can follow it just fine. And so that's omission. Now we go into commission, and errors of commission are memory errors when either the wrong or unwanted information comes to mind. And these are a little bit more in depth, so they're going to get their own sort of descriptions and examples, but we have misattribution, suggestibility, bias, and persistence. So the first, misattribution, is basically when you assume that the information came from somewhere else. So I thought that it was this person in the picture, but it wasn't. It was that person. So this would be a great example is déjà vu. That feeling that you've already experienced a particular sequence of events before. The direct translation for déjà vu is already seen. So you walk into a room and go, oh my goodness, I have been here before, I have done this before, what's going on? And it's not always the fact that it's actually something you've seen or done before. Sometimes it's something else going on. And there's a whole bunch of really cool theories of déjà vu. Some of them say it's because our two visual processing sort of pathways have different speeds. So it's kind of like the left eye information arrives just a fraction of a second sooner, and it develops a feeling of familiarity. There is also the idea that, well, our lives are very repetitive, and maybe it just feels familiar because it is. So it's not the same place, but it's the same feeling, so it counts. There's a whole bunch of different ideas to it. But yeah, it's basically we think that something has gone on, but it hasn't. So the information is wrong. Next is our suggestibility, and this is related to our misinformation effect. And we've actually kind of already talked about this. So this is a phenomenon where misleading information can alter someone's subsequent memory. And this is a big thing for eyewitness accounts. So in cop shows, you always see that they separate their witnesses. And on the surface, it's so that people who are in on it don't get their story straight. But it's actually also important for non-involved people, because if they hear someone else's story, their own version of events will sort of morph to incorporate that extra information. So we are very suggestible, and we will include extra information if we hear it, and we don't even realize that we're doing it. And that kind of relates to the next idea, and this is the idea of bias. And so our ability to sort of incorporate extra information doesn't have to come externally. We also typically use schemas. And we've talked about schemas as like mental shortcuts. So we have a tendency to leave out information because it's irrelevant. So if we're thinking of a classroom, instead of remembering every detail of this classroom, I'm like, yeah, it's a gray box and there's some chairs and tables. And I'll fill in the gaps as relevant. So I wouldn't necessarily know exactly how many tables and chairs there are, but I'd have a decent representation. So we have highly organized knowledge structures where we fill in gaps naturally, and that's just how we store information, almost to save on space. And so stereotypes could be an example of schemas. So we might sort of assume extra information that also matches that stereotype, because it's easier to remember this person fits this generic, maybe they're an emo person. And I'd go, okay, well, maybe they also had like poor posture or whatever. And so your categorization might be accurate to summarize, but it's also going to add potentially extra details that weren't there. And there's a really cool study they did looking at automobile accidents and how individual words and terms can change your entire memory of a scenario. And there's a bunch of different ways they've done this. They've shown people still images. They've shown people like simulated crashes using like modeling. And then they'll show sort of within a group, they'll show everyone the exact same thing. But the questions are different. Some people would be asked, how fast were the cars going when they bumped into each other? When they hit each other? When they smashed into each other? And depending on the word that they used in the sentence, despite the fact that they saw the exact same either still image or moving image, their estimate of speed dramatically changed. So if they asked how fast were they going when they bumped into each other, very slow. How fast when they crashed into each other, very, very fast. And the people who were asked about when they crashed into each other, they were a lot more likely to remember glass and car damage, even if there wasn't any in the image. So it's remarkable how much it changes. And every year, I usually do this, I didn't do it this year, but I have a TED Talk about someone who studies eyewitness accounts and the sort of suggestibility of their accounts. And what I'm gonna do is I'm gonna go find that from last year, and I'm gonna link it on Moodle because it's a really neat, it's only like 10, 15 minutes, but she is the expert on how we remember things wrong. So I will share that because it's really cool. All right, and so all of this tells us that memory is a constructive process, and we might even call it reconstructive because each time we access a memory, we're sort of almost remembering the previous construction of it. So every time we recall it, we're rebuilding it using all of those shortcuts that we have. So we're putting together bits and pieces of information in a way that intuitively makes sense, but isn't necessarily accurate to what we actually saw. And the more we recall it, the more that we assume that what we're recalling was accurate. And it can introduce new biases every single time. So those schemas that we have, those mental shortcuts, can lead to more and more distortions over time. And as a quick example of how misremembering can work and the fact that we have some consistent biases, there's an experiment where they show students sort of an image like this. They would show it very, very briefly, and then they'd go back and they'd say, okay, draw what you saw. And you weren't paying a whole lot of attention. So you're like, okay, well, I saw a bear. I know what bears look like. And there were stairs. I know what stairs look like. So we get something that looks kind of like this. So a generic cartoon bear on some stairs. And it's like, it's not wrong, but they missed the fact that it was a panda. And it was also much more focused in. And that's something that we do, is we actually expand the boundaries of stuff when we remember it. We assume sort of out of the edge of what we could have known. And so we do this very, very consistently. And then even the next time, if you were showing them images, they might recognize something that's more similar to what they drew than what they actually saw. So sort of that fluidity of memory, which is very, very cool. And then our last of the errors of commission, because we were still on that, that is persistence. And this is when we have sort of unwanted memories. And this is particularly problematic for post-traumatic stress disorder. So individuals with PTSD have memories that sort of pop to the front of their mind. They're very difficult to suppress, and they might even be consciously trying to get rid of them, and they physically can't. So they have constant flashbacks and sort of intrusive thoughts that just won't go away. So that would be another type of error of commission. And we typically experience a much lesser sense of this. So maybe you do something embarrassing and all day it keeps popping up and you have that cringe feeling and you're just like, don't think of it, it's fine, like don't ever think of it again. And it's gonna play on repeat every time you stop for the rest of the day. And then a brief step back from forgetting to talk about remembering, and specifically over-remembering. So this disorder is called hyperthymesia. And if we break it down, mesia reminds us of amnesia, which is an absence of remembering. And so this is hyper, meaning over remembering. So hyperthymesia is a rare medical condition where you have near perfect autobiographical recall. And that basically means that these individuals remember absolutely everything that has ever happened to them. And so sometimes their memories go much further back into childhood than in most people. And they can tell you exactly what day it was when a particular event happened, or this date, it was a Tuesday and the weather was like that. So they have all of these extra details that they can recall. And there are actually differences in brain structures for individuals who have this condition. So the amygdala is much larger in these individuals, and that might be because our amygdala is responsible for emotional processing. And if we think about memories with an emotional component, kind of stick a little bit better. And they're only remembering things that happened to themselves. So maybe that's being more active because they're remembering how they felt, maybe. And then there's also a lot more connections between the amygdala and the hippocampus. And our hippocampus is really important for storing and retrieving memories. So maybe that's something to do with how they're recalling it so well, but they don't really understand how it works. But it's kind of neat that at least something with extreme memory does involve the hippocampus, as we should expect from what we've learned. For some other kinds of forgetting, things like infantile or childhood amnesia, this is just the fact that we don't remember our childhood. Anything prior to the age of 3 or 4 is pretty much gone as adults. And this is nearly a universal experience. Pretty much everyone has almost no memory of childhood. So your earliest memories are probably around when you were 4 or 5. And they, again, don't quite know why. There's a couple of proposed theories that have some support. The idea is when we're younger, our brains aren't fully mature. So maybe the areas involved in encoding and storing just aren't active yet. Or maybe we haven't processed things enough for them to be properly encoded. They're not quite sure. We also typically see dementia. So this is impaired memory and other cognitive deficits that go along with brain degeneration that interferes with normal functioning. So we have sort of a lesser case of dementia. As we get older, we see cognitive declines with age. And we do have methods of sort of protecting against that, along with the idea of if you don't use it, you lose it. If you do use it, you can protect it. So they have been doing a lot of things in retirement homes, encouraging their residents to play games and to do new things. Especially, strangely enough, stuff like getting them to play interactive games on a Wii has done remarkable things for staving off old age dementia. And it's just because it's using the brain and keeping it active longer. There are other disorders and diseases that will sort of overcome that. So we have things like Alzheimer's disease that leads to severe retrograde and anterograde amnesia. And if we see the parts of the brain that are involved, it kind of makes sense because that looks fairly similar to those central structures that are fairly important for memory formation. But it starts in the temporal lobes and spreads out to the frontal lobe and then other cortical regions as well. And this causes pretty intensive memory loss and other sort of cognitive deficits. All right, and then the last little bit here, I wanted to talk about what is it that is going on that allows us to remember? Because we've been talking kind of high level, macro level stuff, but we haven't really talked about what's actually going on that allows us to remember. And we're not going to go into tons of detail because we do not have enough time in this class to go into some of these. But we can mention the fact that, yeah, there's a biochemical level of memory. So if we think at the level of synapses and things happening within synapses, so maybe there are different chemicals present, so hormones and neurotransmitters, their concentrations and their actions might be adjusted at the level of the synapse, and it might alter the transmission across those synapses. We also have the production of different proteins. So proteins would be synthesized that can affect how different things are interacting. And these different chemicals, this biochemistry in our brain, can change as we learn and experience things. So here talking about memory in terms of things that we've learned and have stored away. We can also step back and look at things like neural circuitry. So instead of just the synapse itself, all the connections between multiple neurons. And we have sort of a localized neural circuit. And we can think of patterns of firing within the neurons, potentially storing different information. And we know that as neurons fire together, they create more connections. So we'll actually see what's called neurogenesis, where you get extra connections between neurons. And that's more likely to happen as they fire at the same time together. We also see long-term potentiation, where once a pathway has fired, it's easier to fire again for a short period of time. So we have this sort of strengthening of stuff that we're using more and more. And this is kind of related to some of the ways that we can conceptualize information. And there are two major ways of framing things that are typically seen in memory research. The first is associative networks. And this is more of a conceptual theoretical approach. So this is saying that we're representing memory as a network of associated concepts. So you can kind of think of it as like a whole spider web where each point that the lines cross is a node, and each node is representing a concept. And so the lines between the concepts would represent different associations. Shorter lines means a closer association. And so I've shown a very simplified version here, because if you actually look up associative network diagrams, they are massive and multidimensional, and it is awful. So this is a simple, 3 concepts in a line. So fire trucks might make you think of fire. Fire makes you think of heat. And we can, of course, connect other concepts. So maybe you group fire trucks with ambulances and police cars, because they're all emergency vehicles. And fire with, other elemental things like water and air. And then heat could be with things that cause heat, or heat and cold and other sensations. So all of these things that kind of pop to mind. It actually feels kind of Freudian, if like word associations and what does it make you think of. But the idea here is these are all connected together, and these connections actually allow us to explain things like priming. So the concept here being, okay, well, if we activate the concept of fire truck, we also think a little bit about the concept of fire, and vice versa. So if we were talking about fire and somebody asked us what to name an emergency vehicle, we'd be more likely to say fire truck than ambulance. So priming works where if a particular pathway has been activated recently, we're more likely to pull from the sort of surrounding areas because they've also been kind of ripple activated as well. And so we can find, that's what these associative network maps do, is look at how these connections form and then how it carries. So if we talk about this, what else does it overlap with? What else do you think of more likely? So there's lots and lots of research on that. And so that's if you're focused on the theory side of things. The other way to go about this is, okay, we don't care about where each individual concept is. We care about what's happening with the cells, what's going on at the neural level. And this is our neural network theory. It's also called the parallel distributed processing model, which I've never actually seen in practice. Neural networks is much better to say, and it fits better in titles. But they basically look at the distribution of firing across connections of neurons. So we're still talking about linked nodes, but here we're looking at physical links, connections between neurons, as opposed to theoretical links, connections between concepts. So here we're saying that, okay, so our nodes are something physical. These are the connections between our neurons, and they don't represent a unit of information. They're just physical things that we're looking at. And so with a neural network study, we could look at how these neurons fire together. So maybe we wanted to do brain scans and say, okay, I'm going to play a sound or show you an image, what parts of the brain light up, and what series of neurons start firing together. So the idea being that a concept would be sort of represented as a pattern of firing as opposed to something sort of theoretical. And again, this isn't that sort of one or the other is correct. This is just the easiest way to frame it to try and explain the literature. So you typically see sort of one of those two schools used. And then the last little bit are actually mostly just reminders of things that we've talked about. So talking about anatomy involved in memory. So we've mentioned our cerebral cortex and the prefrontal cortex and the hippocampus and the amygdala and the cerebellum, and they all have different roles. So our prefrontal cortex does a lot of that interconnectedness where it sort of combines information and helps us fill in some gaps. The cerebral cortex, the rest of it is where information is processed, but also where our sort of memory things might be stored. We saw that in the video about HM. We know that our hippocampus is directly involved in storage and retrieval from long-term memory. Amygdala is related to emotions and potentially sort of remembering the emotions associated with memories. It also is involved in the fact that emotionally charged things are easier to remember. And then our cerebellum is involved in sort of our procedural memories, how we can do things and actions, and doesn't necessarily need the hippocampus. But those are the ones that we've talked about, and that's kind of the level at which we need to know them. And then for our systems and types of memory, again with the sort of review and refreshing of terms now that we've talked about them even more. We can talk about things being implicit or explicit. And we mentioned explicit as things that we can talk about, things that we can discuss, things that we intentionally can tell you about. And implicit, I had kind of compared to being non-declarative, where you can't talk about it. But we could also say that implicit things are things that you don't know have happened. So you can't talk about them because you don't know about them. And in that way, you can actually apply implicity to things like priming, where a certain term is more likely to come to mind because of sort of neural activation that you're not aware of. So you don't know that you've been primed, but you have. So we could use implicit in that way as well. We can also have our sort of declarative versus non-declarative, where declarative is the stuff we can talk about, and the non-declarative is our procedural stuff that you can only do. We distinguish between semantic and episodic, where episodic is the stuff that has happened to us, things that we've experienced, the episodes of our lives. And then semantics are our facts and the things that we know. And then the last one is something that we've been talking about, but we haven't realized we've been talking about. And this is the difference between prospective and retrospective memory. And pretty much everything that we've talked about up to this point has been retrospective memory, remembering things that have happened. Prospective memory is a special case, and we actually have it as remembering to perform a task in the future. So you have to remember that you need to do something. So it's not like you're remembering something that already happened. It's sort of I have these actions that need to occur. So it's a separate system, and it's so people who have sort of good retrospective memory don't necessarily have good prospective memory because they aren't necessarily directly related. But to be able to plan for something in the future, you have to have planning and attention. So you need to know what you are needing to do, you need to know when to do it, and then you have to remember to do it when the time comes. So it's a whole lot of other processes. And this is mostly going to involve our frontal lobes because of all of these executive processes, because so many things have to come together and work together. And prospective memory is one of those things that they've started using it as a measure of intelligence and self-awareness. There's some really neat studies that I've been looking at with birds, remembering things that will happen, and planning for things that will happen in the future. So it's starting to change our idea of planning being a human-only thing, because we're seeing other animals that will bring tools with them to do a task in the future, which is very cool. And we do see a decline in our prospective memory as we get older. So most studies have shown that as we get older, we just get forgetful. Some of us have always been forgetful. But as we get older, we actually start making little tips and tricks to kind of overcome that. So maybe we develop a routine. So you always put your keys in the same spot, so it doesn't matter if you don't remember where they are, because they're always there. Or maybe you have sort of tricks, writing it down, sticky notes. I like setting alarms with descriptive names so that I remember what I'm supposed to remember to do. Lots of things like that. And then as you get older, you can have those protective factors to help you out, but it is going to have a pretty steady decline eventually. And then the last topic is the idea of motivated forgetting. And this is called repression. So when you block memories. And so the idea is that repression would be sort of saving yourself from anxiety arousing memories by blocking them away and suppressing that memory. And this sounds very Freudian because it's based on a lot of Freud concepts. And there's some debate over whether it's a conscious or unconscious process. So sometimes people intentionally don't want to remember something and they push it away until that pathway sort of deteriorates. In my experience, stuff that you really don't want to remember and you're trying to block out tends to sort of intrusively come back and then you remember it forever. But there's also some talks of it being an unconscious process, like your mind is protecting you from, say, a traumatic event or something like that. But this is one of those things where the research is very aggressively in disagreement as to what's going on and if it's even a thing. Hence the question mark about motivated forgetting. We're not quite sure, but it's always interesting to talk about. But that is it. That is memory. And that's